Hey everybody, this is Gregory from Dapp University. So welcome back to this multi-part tutorial series where I'm showing you how to build a full-length blockchain application step by step, all right? So if you're just jumping into the series, go check out the previous videos if you haven't already, all right? In case you missed it, I'm releasing these videos over a series over a couple weeks on my channel, and I'm gonna release one giant video at the end with a full-length article on my website that'll show you how to build this out step by step. In the previous video, we continued out building on the smart contract, and in this video, we're gonna finish it off, all right? So let's go ahead and jump in and start programming. All right, so let's go back into this smart contract, right? In the last section, we created posts with this function. We want to do a few things inside this section. We want to continue out our tests. We want to, list the posts and then allow users to create posts. So we'll create, a function for that also inside this smart contract, okay? So while I'm here, I want to clean things up a little bit and make a mention of a few things. At the end of the last section, I mentioned gas. So this is a topic we haven't talked about much yet in the tutorial. So what is gas? Well, I'll explain it this way. Anytime you write new information to the blockchain itself, you have to pay a gas fee, all right? So anytime you send cryptocurrency from one account to another, you must pay a transaction fee for doing this. Likewise, anytime you create a smart contract or you call a function that actually updates the blockchain itself, you also have to pay a gas fee. So whenever you're calling functions inside Solidity, there's two types. There's reads and there's writes. So reads are free, but writes cost gas because they actually change the blockchain. And anytime you're sending cryptocurrency from one account to another, they also have a transaction fee associated with it, and they cost gas. All right, that's what this is. It's basically a transaction fee paid in Ether, the Ethereum's native cryptocurrency, and you must have Ether in order to create transactions on the Ethereum network. Okay, and so if you notice, if you open Ganache, you'll see that the balances have gone down. Right, so there's 99.85 Ether, 99.98 Ether. They used to be 100. Well, why is that? Well, this first account right here is the deployer, right? If you go to our test, you'll see this is the deployer. This is the first account in the list, right? This is the deployer. This is the tipper, the second account in the list, or sorry, the author, second account. And then this is going to be the tipper, all right? So the tipper hasn't created any transactions yet, all right? But the author has. So whenever the author was creating his post, he created a transaction on the blockchain, all right? And this cost a gas fee. Same for the deployer, which happened every single time that this function was called. It also had to pay a gas fee, and that's why this account balance has gone down. You see it's less Ether than the rest of these, okay? And then as soon as we create the tip functionality, the tipper's account balance is also going to go down by the tip amount and also the gas fee. Now inside the test, let's go ahead and do a little cleanup. So you'll notice that I used a before hook here before we did the deployment. I'm going to do the same thing for the post, okay? So just before this, creates post, I'm going to move this up a line, just like this, and I'll use a before hook. I'll say, boom. Before async, result is equal to this, right? So we'll track the result in the post count inside of here instead of, rather than doing it here inside the example, because we want to use these values, result and post count, inside these examples like this. All right, so I'll uncomment this out. And now inside of here, we'll be able to access, the result and the post count as well. So now in order to test for this, for listing posts, we're going to call the post function, okay? Just like this post function right here. And we're going to pass in the post count from this right here. And we're going to, read all the values and ensure that the post has, the correct values, just like this, ID, content, tip amount, and author. So I'll say const post equals await social network dot posts. All right, pass in the post count. This will be the latest post. And now we can inspect the values like this. We'll just copy this right here and then paste it in here. Boom. So instead of event, we'll say post dot ID to number is equal to the post count. All right. That the content is equal to the content, tip amount, and author. So save that, run the test, go to the terminal, say truffle test. All right, should be a new example for listing the posts. Awesome, lists all the posts. Perfect. So this is just a way of fetching one post. And when we create the client-side application and we actually list out all of the posts, what we'll do is use the post count and use a loop to check each post individually. We'll call this post function and fetch it with this function just like this. That's because we have to do it that way, which I'll revisit later, because in Solidity, there's no way to know how big this mapping is natively, and there's no way to iterate over it either. We can't just say like post.all or post each. We can't just return it. We have to know how many are inside of there, and then fetch each one out individually with this post function. And I'll show you how to do that whenever we create the client-side app later. But for now, we know that we can fetch a single post. And if we can fetch one, we can fetch all of them. All right, so let's go ahead and move on to the last part of the smart contract for the social network. Let's do the tipping functionality. So this is the example we're going to use here, okay? So inside of here, we're going to create a new function called create tip, or tip post, I should say. Say function tip post. Say uint ID. We're going to pass in the ID of the post we want to issue a tip for. And we'll write all the function code inside of here. This post is also going to be public, just like the other one, because we want to be able to call it from the test and call it from the client-side application. All right. And this function needs to do a few things. First, it needs to fetch the post. Then it needs to fetch the owner from the post, or the author, I should say. Increment the tip amount on the post whenever the tip comes in. I should update the post. It should pay the author. And then finally, it should trigger an event. That's a lot of stuff. And tell you what, let's actually pay the author up here before we increment the tip amount. So let's see how that works. First, we're going to fetch the post from the blockchain. All right. So we can fetch it out of this mapping, right? You could say posts, and then pass in the ID right here. All right. That's how we read it, just like we write it. And then we're actually going to store a copy of this in memory. Okay. So we'll do that like this. We'll say post memory post equals post ID. All right. So what this will do is create a new copy of it, and we will, update these values, and that won't actually affect the post on the blockchain. Okay. It won't affect it until we reassign this value here later. Okay. So we'll update the post. We'll go ahead and do it now before we manipulate it. We'll just say posts ID equals post. All right. So we're going to fetch the post, create a copy, and then put it back on the blockchain later. But in the meantime, we're going to, fetch the author, pay the author, increment the tip amount. That's going to change the post itself, and then we're going to put it back here. All right. So we can simply get the author like this. Say address author equals post.author. Pretty simple. All right. And then, we can increment the tip amount and also pay the author. Okay. So let's do that. We'll say post.tip amount equals post.tip amount plus, this value. So we need to add the actual tip that's coming in. Well, how do we do that? All right. This is really confusing because all we have here is one argument so far. We just have the ID of the post that we want to pass in. So where's the actual tip? Where's the cryptocurrency itself, right? We're tipping this post with Ether, Ethereum cryptocurrency, but how do you tell this function that you want to tip Ether? There's no argument for the amount. That's because Solidity allows you to use some more function metadata just like this to track the amount of ether that gets sent in whenever this function is called, okay? So we can say msg.value. All right, this is going to be the actual amount of ether that gets sent in, and we can update it just like this. So post tip amount is equal to post tip amount plus the amount of ether or Ethereum cryptocurrency that's sent in whenever this function is called. So if you go back to the test, we're going to be able to say value just like we did from, right? So that's another example of metadata, or you can say it like this, value equals ether. Okay. All right, we'll see that here in a minute when we go back to tests. But for now, we can also pay the author address, and we can pass in the author. And then we'll call a function called transfer. So this is a Solidity code that tells us to send ether to this author right here inside this function. And we'll just say msg.value. We'll say pay the author by sending them ether. Okay? Boom, done. And then lastly, we want to trigger an event just like we did here. So post created, we want to say, post tipped, all right? So we'll create a new event just like that. We'll just copy this post created and paste it below. Say post tipped. And we'll use the exact same arguments: ID, content, tip amount, and author. So there's one more thing we need to do in order to pay the author. We need to change how this function works. In order to create a function in Solidity that accepts ether, we have to call it payable. Say payable, right? We add that modifier right here. That will allow the user to send in Ethereum cryptocurrency whenever they create this transaction, which we'll see here in a minute. All right. Likewise, we also need to say that this address for the author is also payable, okay? We're going to do that in a few different places. First, we'll do it here. We'll say payable, address payable, author, right? We'll also do it here inside of the post, so address payable. This is a special data type, address payable author, and then also address payable author here. All right, that should be everywhere that we need to change in order to actually pay the author here. All right, so let's save that and go back to our tests. Let's write a test to see if this works. And I want to go ahead and call the tip function and basically tell it how it works. So I'll say result equals await social network dot tip post, and then I'll pass in the latest one. So we'll say post count. All right, and then we're going to pass in the metadata. So we need to tell it who's going to do this. So previously we did from author. I'm just going to copy this and paste it here. In this case, it's going to be from the tipper. All right, so I'll copy that and paste it here. And next, we want to send in some Ethereum cryptocurrency with this, metadata that's going to get interpreted here as msg.value. So just like this was from, went to msg.sender. In JavaScript, value is going to correspond to msg.value, right? And that's what this message function metadata is. Okay. So now we want to tell it how much ether we want to send in. So let's tip the post, 1 ether. Let's just be really generous and give him an entire, 1 unit of Ethereum cryptocurrency. Now, we don't want to just say 1, right? That's not actually ether. So why is that? Well, Solidity uses something called way to store all ether values. All right, let me explain what that is. So 1 ether can be divided into 18 decimal places. All right. That means 1 followed by 18 zeros. All right. So essentially, like a US dollar can be divided by, 2 decimal places. It's 1 followed by, 2 zeros to determine how many cents or how many pennies make up $1. This is a similar kind of thing. This is how many Wei make up 1 ether. This is sort of like a really tiny penny in Ethereum. This is the smallest unit of the Ethereum cryptocurrency itself. Okay. So all the values inside of Solidity for Ether are stored in Wei. That's because we don't use any floating point numbers to store on the blockchain, right? We just use integers, all right? So if you're going to do that, you can't store any decimal places. You have to store, basically numbers, like integer values. So that's why we use Wei. So anytime we see something like MSG.value, this is not going to be an ether value, it's going to be a Wei value. So if you want to say 1 ether, 1 ether is going to be, 1 ether is going to equal, 1 followed by 18 decimal places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 Wei, all right? So if we send 1 ether in when this function is called, we're sending in exactly that many Wei. Okay, so there are some utilities that help us do this. So you can't just say 1 here is value. You actually need to say, this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. But that's kind of crazy, right? We don't want to do this every time we want to just say 1 ether inside of our tests. So luckily, there are some helpers that we can use. We can use the Web3 library, which is included inside this test suite. We're going to use Web3 a lot when we create the client-side application, and you're already using Web3 under the hood. We can say web3.utils.toWei. All right, we say 1 and ether, right? And that's going to convert this to the Wei value and give us, 1 followed by 18 decimal places without us having to write all that out ourselves, which would be kind of ridiculous. All right, so that's how we tip the post. We tell it the post we want to tip, we tell it who the tipper is, and then we tell it how much cryptocurrency they want to send. In this case, it's 1 ether, which is going to be 18, or 1 followed by 18 decimal places Wei. All right, so after the tip is issued, we're going to guarantee its success, just like this. All right, say success, and instead of, the post count changing, we're just going to, dig into the logs and check that the ID of the tip was, correct, all that kind of stuff. So that's fine. ID is, we'll just use this same template from this. We'll say ID, content. So tip amount is going to change, all right? So we'll just be explicit about it in this case, just so that you can see what's happening. We'll say 1 followed by 18 decimal places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's the tip amount, all right? Tip amount is correct. And then the author is also correct. So the tip amount should have changed whenever this happened, all right? Okay, so let's just save this, and that'll be our first check. So I'll say triple test. All right, it looks like we had a little bit of a compilation issue. So I'll go back to the source code, and yeah, I forgot to do this. Say post underscore. All right, save that. Run the test again. All right, it looks like we have one more problem. It says, can I read property args of undefined? So I know what this is, but I'm going to reason through it for a second just so that you all can understand. So this says that args is undefined. Well, that's because there's no actual event listed here. That's because we forgot to trigger it inside this function, right? We left a note for ourselves, trigger the event, and we created it, but we never actually called it, okay? So we got to trigger the event, and we'll just say, post tipped, right? And boom, post tipped. Pass in the count, the content, tip amount, and author. Save that, run the test. All right, it passes. So we're getting really close. The next thing we want to do is check that the author actually received the tips. So what I'm going to do is essentially check the author's cryptocurrency balance in their wallet before the tip was issued, and then also check it after the tip was issued and compare the two and just make sure that the new tip amount is bigger than the old one. All right. So I'll just say track author balance before purchase. I mean, this is a little faster, but I'll explain it because I want to move on. Say boom. All right. So let the old author balance equal this. So we'll say Web3 ETH get balance. That's how you check the balance of someone's wallet. All right, passing the author. And then we're going to convert it to a big number, all right, in JavaScript like this. Web3 utils big number, old author balance. All right. And then what we want to do is check that the author actually received the funds after this success. So we'll say success. Sorry, move this too. Say boom. So new author balance. So here's the old author balance, new author balance. Same thing. We just check the balance of the author again. All right. Just like we did here. And then now we're going to factor in the tip amount. Say boom. Let tip amount equals this, Web3 utils two-way, 1 ether. And I guess we could, refactor this up here, but we'll just leave it for now. And now what we'll do is say expected balance equals these two things added together. Boom. So old author balance, add tip amount. All right, so you can pause this on your screen if you want to try to make sense of this more. But finally, what we want to do is compare the two, the new author balance and the expected balance. And we want to say that they're equal. Boom, like this. New author balance to string. All right, we're going to coerce these to strings and say expect is equal to the expected author balance. All right, so you can pause this and take a look if you want to. All right, so I'll run the test. All right, it passes. Finally, I want to ensure one more test case. We want to fail, say failure. So ensure, so say tries to tip a post that does not exist. So essentially what we want to do is ensure that a valid ID is passed in whenever the tip post function is called. So do that just like this. Boom. We'll tip post 99, which doesn't exist yet. We'll do it from the tipper. We'll pass in 1 ether. And this should be rejected. All right, this transaction should not go through because post 99 doesn't exist. We'll do that inside of our smart contract. All right, with a require state, with a require function, just like this. So require bytes constant length equals true, right? For create post, we're going to do a similar thing here for tip post. Boom. Require that the ID passed in is greater than 0 and it's less than or equal to the post count. All right, so if it's outside this range, we'll consider it invalid and we won't let you issue a tip for it. Okay. All right, so that should be it. Let's clear out this space. Do the same thing for our test. All right, clear out this space. All right. And then say triple test. See they pass. All right, it passes. Congratulations. That completes our smart contract and the test suite as well. All right, so now that this is done, let's go ahead and deploy this smart contract to the blockchain and get ready to build the client-side application. We can deploy the smart contract like this, say truffle migrate -- reset. And what the reset flag is going to do is put a new copy on the blockchain, all right? Remember, you can't update smart contract code. All you can do is create a new copy of the smart contract. And that's exactly what this just did. It put a new copy on the blockchain and updated the address inside our Truffle project to point to the new copy, not the old one, okay? So now you should have everything that you need in order to start building out the client-side portion of the application that we're going to do in the next section. So congratulations, you've done a lot of good hard work. We've got a complete smart contract that we can use to power the social network on the blockchain. So this is great. Now we're going to go ahead and build a client-side application to use this and build out all the user-facing features. So I'll catch you in the next section.